All right, y'all. So 5.1 deals with rational expressions. And in order to do this section without any hassles, I'm going to give you a review over factoring. So this will be a factoring review. And I'm mainly just going to go over the greatest common factor and factoring trinomials, okay? So the first thing I'll do would be the greatest common factor. So let me throw some examples up here. So an example of greatest common factor, my first one, I'm going to do an x squared minus 2x. So the greatest common factor is the largest factor that two or more terms have in common. So if you notice, I got an x squared and a 2x here. The largest factor they both have in common is an x. So you would factor that x out. Inside the parentheses, you would put the quotient that's left after taking both these terms and dividing by the x. So if I had an x squared divided by x, that's going to leave you 1x minus 2x. If you divide that by the x, the x's would cancel, and all that's left is the 2. So this is now factored with the greatest common factor. And that's the trick on those, is find the largest factor and factor it out. So y'all, what if I had something like a T4 minus 3t to the third? So the greatest common factor for these two terms, you got 4 t's here, 3 t's here, would be the t to the third. Then you would divide both these by t to the third and put what's left in parentheses. So t to the fourth divided by t to the third. Remember, when you're dividing, you're just subtracting exponents. So 4 minus 3 would leave me 1t minus 3t to the third divided by t to the third. The t to the thirds would cancel, and all that's left is the 3. So we'll do one more greatest common factor. So I have a 4x to the third minus 8x squared. So this one will have a number and a variable as the greatest common factor. So between 4 and 8, the largest factor they got in common would be the 4. So I would factor out a 4. And then between the x to the third and x squared is the greatest common factor. So I'm factoring out a 4x squared. So when you're looking at variables, you always pick the smallest variable for your greatest common factor. All right, y'all, look at this. 4x to the third divided by 4x squared would leave you just 1x minus 8 divided by 4 leaves you 2 there. The x squared and the x squared cancel. So all that's left is the x minus 2. Oh, good job. You got that right there. Good job, Kara. So y'all, that's factoring out the greatest common factor. Now I want to look at factoring trinomials. So I'm going to put 4 problems up here doing trinomials, and I'm going to show you some tricks on these. So the first one, I want to make everything positive. So how about 7x plus 12? So everything's positive. My second one, I'm going to do a negative in the middle. So how about a negative 9x plus 20? So the last one's still positive, but the middle one's negative on that one. 3, I'm going to do a x squared plus x minus 20. And then my last one, I'm gonna make both of them negative. So how about a negative 7x minus 30. So factoring trinomials, they're going to factor into two sets of parentheses. Now, I'm going to write some rules on these. So notice on the first two I got here, the last numbers are positive on these two. So here's a trick. If the last number is positive, both my factors have the same sign as the middle number. Now, that's going to tell me how to set up my parentheses by my signs. Now, I also know this. Find factors of the last number that add to get the middle number. So these first two are going to follow this pattern because I got positive numbers at the end. That's a positive 12 and that has a positive 20. So this one tells me, come in, make your two sets of parentheses. Since I got an x squared in the front of my trinomial, that means the only way to get an x squared is if I got an x and an x. So positive last number means both of these factors will have the same sign as the middle. So since the middle's positive, both these factors will be positive. Now, the only trick is for me to find factors of the last number, which is 12, that add up to get me a 7. So y'all, can you find me factors of 12 that add to get me a 7? So definitely 3 and 4. And since they're both positive, it don't really matter which one you put where. So I'm just going to put my 3 and my 4. So that is now factored. And if you want to check it, 3 plus 4 give you 7. 3 times 4 equals 12. So the numbers got to add to get the middle, multiply to get the last one. All right, y'all, same thing here. I'm going to draw my two sets of parentheses. X squared means I got an X in front of both of these. The last one's positive. So that means the factors will both have the same sign as the middle number, which is 9. So since that 9 is negative, both these factors will be negative. So y'all, if the last number is positive, you got to have like signs on these factors. All right, so the only trick now is for y'all to find me factors of 20 that add to get 9. Oh, you done factored that out. X minus 5, X minus 4. Good job. So y'all, factoring is not too bad if you play with the signs you're given, okay? So notice both these examples, I had a positive number at the end, so I had like signs on them. These two examples have a negative at the end. So it's a little bit different game. So y'all, if the last number is negative, factors have unlike signs. So that means one will be positive, one will be negative every time if that last number is negative. So the factors have unlike signs. I'm going to find factors of the last number. That subtract to get the middle number. But really, when you're adding unlike signs, the rule is you subtract and get the sign of the larger number. So that's why I just say subtraction on those. Now here's the kicker. The larger factor. So when you find your two numbers, the larger factor has the same sign as the middle number. Okay, so the larger factor has the same sign as the middle number, and that's pretty much every time on these. So watch what we'll do to these. So we'll make our parentheses. X squared is still going to be an X and an X. Since that's negative at the end, I'm going to make one of these positive, one of these negative. So I got my signs. So now, can you find me factors of 20 that subtract and give me 1? Remember, that's like a 1 sitting there in the middle. So what factors of 20 will subtract to give me a 1? So that'd be 5 and 4. So, oh, you've already got my signs. So 5 and 4 were the factors. Since 5's the larger factor, it's going to be positive like the middle. So good job. That'll be a positive 5, negative 4. Now, if you do 5 minus 4 gives me 1 like the middle. 5 times negative 4 equals negative 20 if you multiply. So y'all, same thing here. I got an X and an X. One's going to be plus, one's going to be minus. So let's see what factors of 30 will subtract and give you a 7. So let's see. So 10's larger, it's going to be negative like the middle. So good job. That'll be a negative 10 and a positive 3. So if you add them, 3 and negative 10 equal negative 7. 3 times negative 10 equal negative 30. So this is the stuff you're going to be doing in the support to get you ready for 5.1. So y'all, let's do an example where you got to do everything. What if I had a 2y squared minus 24y plus 72? So remember, the first thing you want to do is to see if you got a greatest common factor. So between 2y squared, negative 24y plus 72, do y'all see anything that all three of them factors might have in common? So, or a little bit too much. So since the 72 didn't have a y, I really can't pull a y out of all three of those, but I can definitely factor out that 2. So this one has a GCF of a 2. So watch this. You would factor out a 2. So you're basically dividing all three of these by 2 and seeing what's left. So 2y squared divided by 2 would leave you a y squared minus 24 divided by 2 would be a 12y. And then 72 divided by 2 would be a 36. All right, y'all, guess what? Now you would try to factor the trinomial. So you got your 2 out front, bring it down. Y squared would be a y and a y. Notice the last one's positive. So both of these factors will be negative like the middle number. So then all we need, y'all, is factors of 36 that'll add to give me a 12. And that'll be the 6 and the 6. Good job. Okay, so be careful. Sometimes you factor out the GCF and then what's left, the trinomial that's left, might have to actually factor further, okay? So that's a review on factoring. So we'll use that when we start playing with this 5.1. So the first thing 5.1 wants us to do is find all numbers for which the rational expression is not defined. So basically, what numbers make it undefined? So for number one, they gave us 9b squared minus 10 over 14b plus 15. So to find numbers which make a rational expression not defined is pretty much the same thing as finding the domain. We're worried about numbers that I can put in for the b that would create the bottom to equal 0. Because remember, if the bottom equals 0, then it's undefined. So to do this problem, we're going to take the 14b plus 15 and set it equal to 0. And y'all, we've done sort of a few domains in this class on fractions. And remember, I'm only concerned about the denominator, okay? I don't care what's in top, it can be 0 or any other number. The only stipulation that I have is the bottom cannot equal 0. So we set it equal to 0 and solve it. So y'all, I'm going to solve this by subtracting 15. That gives me 14b equals a negative 15. Divide both sides by 14. So that b equals a negative 15 over 14. So that means the rational expression is not defined for b equals a negative 15 over 14. So this was just getting you ready. In a little bit, we will find a domain, but this was just bringing back memories of what we had to do to find our domains, okay? So y'all look at this one. Y squared minus y minus 4 over y squared minus 10y plus 24. So once again, I'm only concerned about the denominator. So I'm going to take that denominator and set it equal to 0. And this is why they wanted y'all to refresh yourself on factoring, because this is easier to solve by factoring than it would be by using the quadratic formula. But if you're really weak at factoring, you can use the quad formula to solve this, okay? Because it is quadratic with the y squared. But I'm going to show you how to do this by factoring. In the front, we know we got a y, because the y times a y equals a y squared. So y'all, here's a question. What kind of signs would I put in my parentheses to factor this one? So they both will be negative. Good job. So they both got to be negative. Now, here's the big question. Can you find me factors of 24 that add to give me 10? Six and 4. So since you're both negative, it don't matter where you put them, okay? All right, so now that this is factored, to get your answers, you set both of them equal to 0. That's using the zero product rule, which it says if 0 is your answer, then either one of these factors could equal 0 to make that true. So remember, when you're in factored form, all we're really doing to these is changing the signs to get the solutions, just like finding zeros. So here I would add 6 and get x is a positive 6. So if your factor is a negative 6, your answer will be a positive 6. And y'all the same thing here. Add 4 to both sides on that one. And I get y is a positive 4. So really, once you got them factored, you can change the signs and give me the answers, okay? All right, then the rest of these problems, there's like 6 altogether in 5.1 called the algebra part, is finding the domain. So we're going to find the domain. Of each function. Now, they want me to write in set builder notation. So set builder notation is where they do the parentheses and X such that X is a real number and not equal to whatever. And then they want me to use the interval notation. Interval notations where I use the parentheses and the infinity, and I use that union to kick out answers. So I'll give you a refreshed on both of these. So for number 3, they're giving us f of x equals 3x minus 7 over x plus 7. So remember, I'm actually looking for domains now, so I'm looking for those x values that will work and kicking out the ones that don't work. So y'all, I just got a x plus 7 down here, so we're going to set it equal to 0. So that's why we had this doing these 2 problems so that we would know how to solve for the bottom, okay? Only going to get one answer on this, so when I subtract 7, I get x is a negative 7. So putting that in domain form, set builder would be x such that x is a real number and x cannot equal negative 7. So make sure you choose the one that's got the not equal when you're doing the domain. Now, interval notation will be a parentheses. You're going to start at negative infinity. Always going to start at negative infinity. We're cruising along the x's till we hit negative 7. So since x cannot equal negative 7 for my domain, I'm going to union around that negative 7. So remember, the union means you can get right up to the negative 7, but you cannot equal negative 7. And y'all, since I only had the one value from negative 7, I can head out towards positive infinity. So to kick out a number from the domain on interval notation, we union around it, okay? All right, look at number 4. We got g of x equals 5 over 2x minus x squared. So since I got an x squared term as my highest exponent, I'm expecting 2 numbers to be kicked out of this domain. So we're going to start by doing 2x minus x squared equals 0. Now, that's not a trinomial, so I'm not going to try to factor that into 2 parentheses. But what we can do to this one is factor out a GCF. So factor out GCF. So y'all, you got a 2x and an x squared. What would be the GCF of those 2 terms? Okay, so you got an x with a question mark, but that's actually right. Factor out an x, and then we would set up our parentheses for what's left. Well, 2x divided by x would leave me a 2 minus x squared divided by x will leave you 1x. So I've now got my 2 factors. So I'm going to set both of these factors equal to 0 like I did over here. So I got x equals 0 and 2 minus x equals 0. Check this out. The greatest common factor, if it's a variable, always equals 0. So what we really got to solve is this one. So 2 ways to solve this. The long way would be to subtract 2 from both sides and then divide by that negative. The quick way would be able to come in here, add an x to both sides so that I get 2 equals x. So 2 equals x is the same thing as x equals 2. All right, so it'd be x such that x is a real number and x cannot equal what I have 0, 2. Interval notation. Remember, I'm going to have 2 unions since I got 2 numbers. So I would start at negative infinity. The first number I come to would be 0. So I would union around 0. From 0, I would go until I hit the 2. I would union around the 2. And then from 2, since I don't have any more numbers to kick out, I would go to positive infinity. So y'all, that's the trick on these, is just to keep up with how many answers you should give and play with that bottom, okay? Oh, lost my page. There we go. All right, so I'm gonna do one more of this and then we'll play with that 8-pi stuff. So this would be like number, oh hell, I'll do 5 and 6. So same thing, find the domain. This one has f of x equals 3x squared minus 73 all over 5x plus 13. So notice I only got 1 x here. So I'm expecting only 1 answer to kick out of my domain, okay? So we start by setting that equal to 0. So y'all, this one I'm going to subtract my 13 and then divide by my 5. All right, now let's divide by the 5. So x I get on this is a negative 13/5, which means I need to kick that negative 13/5 out of my domain because it makes the bottom equal 0. So for set builder, we would be x such that x is a real number and x cannot equal negative 13 over 5. And then interval notation. Interval notation would be from negative infinity until we hit that negative 13/5. Union around negative 13/5. And then we're off towards positive infinity. All right, also the last one in 5-1 has a f of x equals x to the 3rd minus x squared plus a x plus 3 all over x squared plus 11x plus 24. All right, so I got a trinomial down here with an x squared. So since 2 is the highest exponent down here, I'm expecting 2 answers, okay? So start out by setting this equal to 0. So do y'all want to guess what's going in these 2 parentheses when I factor the x squared plus 11x plus 24? Because we know they're both going to start with an x, right? So they're both going to be positive. Good job. So remember, last one's positive. So these are both positive, like the middle number. So then say 3 and 8 are factors of 24 that add to get 11. Good job. And then let's see, y'all didn't got that factor. Good job, okay? So now set both of them equal to 0 and get our answers. Yo, I sort of like factoring, especially when I was taught to use them signs the most. Knowing what that last sign was telling me, I always like it a lot better. So here we'll just subtract 3. That's going to change that positive 3 to a negative 3, and this one will change the positive 8 to a negative 8. So x such that x is a real number, and x cannot equal negative 8 comma negative 3. And I always put them in order because on some of these questions, it'll say write the answers in ascending order. That means they want you to go left to right. The first number you would hit, and then the second number you would hit. And I think they're only doing that so that when you do this interval notation, you got them in the right order. So go from negative infinity, negative 8, you would hit first. Unit around negative 8 until you hit negative 3. Unit around negative 3 till you're off to positive infinity. All right, y'all. So that was 5.1, and it was just having you pretty much do domain on those, okay? So what I'm going to get into now, we're just going to get a good start on 8.5. There's no way we'll finish all this today, probably. But we'll get a good start on it, and then we'll be able to finish it in 8.6 on Wednesday. So 5.1 we just did was rational expressions. 8.5 is rational functions. So it'll start out doing a little bit of domains just to keep you squared on that. It has 2 problems doing domains. So let's play with those real quick. And these domains they want in interval notation. So y'all, number 1 has a f of x equals x squared over 11 minus x. So starts out doing the same thing we did in 5.1. Finding the domain, take the bottom, set it equal to 0. All right, so y'all, you could subtract 11, then divide by -1. But anytime I got a single x like this, all I do is add that x to both sides. So then I got 11 equals x. So all I needed was interval notation. So I would start at negative infinity till I hit 11. Union around 11 until I hit positive infinity. All right, number 2, I'll probably have y'all do more of this one. This one is 1 divided by x squared minus 2x minus 35. So set that bottom equal to 0. That's a trinomial, so you're going to factor it. Because remember, that's an x squared, so I need 2 answers. So y'all remember this, x squared would be an x and an x. What kind of signs would I put on these 2? A plus and a negative, good job. Remember, anytime that last number is negative, you're going to have unlike signs on these. All right, so what factors of 35 will subtract and give me a 2? And there you go. So 7 and 5 subtract and get 2. She made the larger one negative because remember, the larger factor always has the same sign as the middle number. So since 7's bigger, it's going to be negative. 5 will be positive. Add that together. 5 and -7 equal -2. 5 times -7 equals -35. So I'll say one thing, if nothing else, after these sections, you already get a little bit better at factoring, right? Let's see, subtract 5 here, add 7 there. And y'all, if you remember just last week, we were starting with these answers and working backwards to get those polynomials. So now we're factoring the polynomials to get the solutions. All right, let's see, interval notation. So we'll start at -infinity. I hit -5 first, going left to right. Union around -5 until we hit 7. So we're going to union around 7 because we can't equal 7 and then head off towards our pos infinity. All righty, so then we start learning about asymptotes. So let me go over what is a vertical asymptote and a horizontal asymptote. So this section will be over asymptotes. So first we'll look at a vertical asymptote. So y'all, a vertical asymptote is an imaginary vertical line that occurs where a graph is undefined. So I'm going to try to show y'all pictures of what I'm talking about. So these graphs right here, this graph would be undefined over here at this -4 and at this +4. So that's what these little imaginary dotted lines are. They're showing me that the graph cannot cross over that because it's not defined at that X value. So since the graph is not defined at that X value, it cannot go over it. So what will happen is one side will try to get close to it and head towards positive infinity. The other side usually will try to get close to it, but it heads towards negative infinity. So that's what we're talking about, little lines that the graph cannot cross. All right. They come in the form of X equals some number. So when you answer these, you just can't put the number. You got to put X equals whatever number it's undefined at. Now, here's the last thing about a vertical asymptote. A vertical asymptote can be canceled out if a factor on top matches that factor on the bottom. If this happens, a hole is created on the graph. And I'll show y'all one of those when we hit it. But what you got to do is you got to check the top and bottom for any common factors. If they have a common factors, that's going to take away a vertical asymptote, okay? Now, horizontal asymptotes. So let me show you them pictures again. So a horizontal asymptote, you see how this graph right here is coming down to the right? It gets closer and closer to the x-axis, but it never can cross that x-axis. It just tries to get closer and closer as it heads out towards infinity. So what a horizontal asymptote is, it's a imaginary horizontal line that the graph tries to approach as it goes towards infinity. Now, I will say this, for horizontal asymptotes, there's 3 cases on those, okay? So we'll look at the 3 cases of a horizontal asymptote.
I'm sorry, I didn't finish writing. What was the
Okay.
horizontal and imaginary line that what?
So horizontal is an imaginary horizontal line that the graph tries to approach as it goes towards infinity.
Okay.
All right, so there's 3 cases to horizontal asymptote. Now, to figure out a horizontal asymptote, I look at the degree. I look at the degree of the numerator and the degree of the denominator. So the first case, if the degree of the top is greater than the degree of the bottom. So if the degree of the top is greater than the degree of the bottom, that means the top is growing a lot faster than the bottom, which would mean there's no horizontal asymptote. So if the top is a cube and the bottom's a square, since the top's growing so much faster, there's going to be no horizontal asymptote because those graphs are going to try to go towards positive infinity and whatever. Now, if the degree of the top is lesser than the degree of the bottom, so basically this one's top heavy, this one's bottom heavy. If the bottom is greater degree and the top is less, then this one would equal y equals 0. That means it's going to try to approach the x-axis as it goes out further and further. And remember, the x-axis is where y equals 0, okay? So they're just going to try to get to that x-axis. So if this was my x and my y, my graph would try to come down and hug that x-axis, but it never can cross it or touch it, okay? So top heavy, bottom heavy. This one, what if the degrees match? So if the degree of top equals the degree of the bottom. If they're equal, then your y is going to equal a over b, where a and b are the lead coefficients. So the degree on top will be the highest exponent, which means it'll be in the leading term. So the number in front of that would be the leading coefficient on the top, and same thing on the bottom. Look for the highest exponent. That's going to give you your lead term, which you can find your lead coefficient from, okay? So that'll always be A over B, whatever the top lead coefficient is, divided by the bottom's lead coefficient. Okay, so vertical asymptotes occur where the graph is undefined. Horizontal asymptotes depend on the degree of the numerator and denominator. So y'all, here comes an example. So this would be like number 3. So this example, they say, list all asymptotes of the function. Then it says graph the function. So usually on the graphing part in this section, they just have you pick a picture A, B, C, or D. So let's see what our function is. Our function is going to be f of x equals 5 over x squared minus 16. All right, so first thing they want to know is the vertical asymptotes. Then we'll find our, now it says oblique asymptote. Every time you come to that oblique asymptote, you're going to put, there is no oblique asymptote. We don't do oblique asymptotes, but they still got them in the questions. So anytime you get to that one, just put no oblique asymptote. And then we'll find our horizontal asymptote. And then we'll pick which graph it is. So to find my vertical asymptotes, we're going to take the bottom of that and set it equal to 0. Now, y'all check this out. There's no variable on top, so there's no way I'm going to have any factors that'll cancel what I'm about to get when I factor this. So I'm going to factor this into 2 parentheses so we can solve it. I got an x squared, so that'll give me an x and an x. Remember, since there's not an x in the middle, treat it like a 0. So first of all, y'all, what kind of signs am I putting in these parentheses? And y'all remember this, that last number is negative. So what's that going to do for my signs? Oh, y'all were saying what? Unlike signs? Anytime the last one's negative, you got unlike signs. Now, y'all, it's like a 0 in the middle. So can you find me factors of 16? That'll subtract to get a 0. That would be what, a 4 and a 4? So this is called the difference of perfect squares when you got x squared minus a number. So it's going to be 1 plus and 1 minus. These always factor into conjugate pairs, okay? So if this was x squared minus 25, I'd put x plus 5, x minus 5. X squared minus 49, I'd have x plus 7, x minus 7. Okay, these always factor into conjugate pairs. All right, set both of them equal to 0. Well, the first one's going to give me a -4. So I get x equals a -4. Second one will give us a +4. So we get x equals a +4. So the vertical asymptotes would be x equals -4, x equals +4. Remember, they got to be in the form of equations. Now, my horizontal asymptotes, let me ask you all this. Does this fraction have a higher degree on the top or the bottom? So definitely bottom. So this is bottom heavy. The top don't even have a variable. So since the bottom has a higher degree, well, we said right here, if the degree of the top is lesser than the bottom, which means the bottom's bigger. So if the bottom has a bigger or higher degree, this will be y equals 0. So you would put that in, and it's got to be in the form of an equation also, okay? And then y'all, let's see, to finish that one out, what number was I doing? They would just have you pick one of these. Now remember, since this was an x squared up here, -16, x squared is positive, so it's going to look like a u for the main graph. And if you look at A, you got the u for the main graph. It's got a dotted line over here at -4. It's got a dotted line over here at +4. So that's what my x equals -4 and x equals 4 gives. And if you notice, as this graph goes out towards infinity and negative infinity, it's going to try to get to the 0 or the x-axis, but never does. So for that picture, we would pick A. Look, B only has one of the asymptotes. D only had one of the asymptotes. And C is upside down. We would choose C if that was a negative x squared. Because remember, the main parabola has to match what that x squared is saying, okay? All right, so I'll do more of those definitely. So let's see. All right, same thing. Find asymptotes and then graph it. So they're giving us f of x equals 6x to the third over x squared minus 9. So I'm going to find my vertical asymptotes, then my horizontal asymptotes. Then I'll be able to pick one of these pictures. All right, y'all, so let's see. So let's find a vertical by setting the bottom equal to 0. Now, I'm looking at this problem. This is one of those that they should have kicked out because of the vertical asymptotes. I mean, that oblique one. So I'm going to show you how to pick an answer on this one. So let's solve this first by factoring. I got an x and an x. The 9's negative, so one will be positive, one negative. Factors of 9, that'll give you 0, would be 3 and 3. Okay, so set both these equal to 0 and solve. So the first one I want to subtract 3. Second one I'll add 3. So my verticals are going to be x equals -3, x equals +3. So this one don't use the horizontal, it has a oblique. So to get the oblique, you're going to take these first terms on top and bottom and basically divide those. Now the oblique will also be a y equals. So y'all, let's see, if we had a 6x to the third and divided by x squared, what would that leave me? Oh, 6x, perfect. So 6x would be the oblique. And on this one, it has no horizontal asymptote. Remember, if the top is bigger than the bottom, it won't have a horizontal asymptote. So y'all, this is the only problem where you got to do that. So look how they did the answer, A, B, C, or D. So we had a 3, -3, and a 6x. So let me see what they're doing to them on these answers. So that one was negative, so that one was wrong. This one has the right oblique, but these 6s are wrong because remember, that should be a 3 and a 3, and the same thing. So on this one, you would have went with A. So remember, the way they're getting this 6x is take the top and divide that by the first term in the bottom. So yeah, I thought they were supposed to take that one out. So sorry about that. And then it had an A, B, C, D. So let's see. Let me zoom that in just a little bit. Well, woo, it's hard to read on my paper. So it looks like these ones are going 2 to 3, but that's going downhill. We need one that goes uphill and goes to the 3. Since that 6 is positive, it'll go uphill. If it was negative, it would go downhill, okay? So the one I need would be C, because it's got the -3, 3 with the vertical asymptotes, and it's going uphill. I don't know what they did there. I think they're using the 6s again on that D. So +6 goes uphill, left to right. But y'all, I'll tell you what, that one was supposed to be kicked out. So if you're doing homework and that's the only problem you missed, email me and I will probably give you credit for that, okay? All right, starting at 5. Find the vertical asymptotes. F of x equals 1 over x minus 2 squared. So set the bottom equal to 0. But y'all remember, x minus 2 squared is just the x minus 2 times the x minus 2. So since these are repeating factors, I really only got to solve this one time. So I'm going to take the x minus 2 and set it equal to 0. All righty, so now solve that by adding 2 to both sides. And we get x is a +2. So your vertical asymptote has to be the equation x equals 2. Question on that one. Now, be careful because I think on this one, the math lab had the x equals part. So all you put on that one is the 2, okay? All right, y'all, 6 has f of x equals x minus 8 over x squared plus 6x. So you're going to want to factor that bottom and see if you get any factors that match the top. Because remember, if you get a factor that matches that top, you got to cancel out that 0 or that vertical asymptote, okay? So it'll make a hole in the graph instead of a vertical asymptote. So we're going to have to take the bottom and start out by setting it equal to 0. All right, so notice the difference. Up here you had x squared minus 9. We had one while ago, x squared minus 16 or something. This one is an x squared plus 6x. So this is not going to factor into conjugate pairs like that one did. Because I got the x term, what I'm missing is the last number. So if you got an x squared plus 6x, you're going to factor out the greatest common factor and solve it that way. So these two have a GCF of a x. So we're going to factor out that x, divide both these by x and put that answer into parentheses. X squared divided by x will leave me at x plus 6x divided by x will leave me my 6. And look at this. The GCF is a variable. So when you set it equal to 0, it's done. Now we would take the x plus 6 and set equal to 0. So y'all solve that one by subtracting 6. And I get x is a negative 6. But notice this. The only factors I got on bottom were an x and an x plus 6. They're not going to cancel with the x minus 8. So I got to keep both of these vertical asymptotes. So my vertical asymptotes would be x equals 0, comma, x equals negative 6. But I do always have to check if I got variables on the top, okay? All right, so let me see. Y'all ready for the next one? And that's why I wanted to practice that factoring, because they're going to throw different things at you. 2 terms, 3 terms. So we got to be careful what they hit us with on those. All righty, number 7 has f of x equals x minus 6 over 1 minus x. So there's no way this bottom factor will cancel out the top. So let's set the bottom equal to 0. And y'all, really the quickest way to solve that again would be to add an x on both sides. And I get 1 equals to my x. So my vertical asymptote for that one is going to be x equals 1. And again, they put the x equals. So all you got to do is come in and put that 1 in there, okay? All right, so 8 has this. F of x equals negative 3 over x plus 4, x minus 1. So we're happy for number 8 because they done got the bottom factored. And there's not a variable on top, so I'm not going to cancel any of my asymptotes. So since this one's already factored, Set both of those equal to 0 so that we can get our vertical asymptotes. So y'all, the first one, you're changing the sign, making it a -4. Second one, we'll add 1 and change it to a +1. So my vertical asymptotes for that one would be x equals -4, comma, x equals +1. So, y'all, to me, vertical asymptotes is pretty much the same as doing the domain, other than we got to check for the top. So let's see about 9 here. F of x equals x squared plus 2x minus 15. The bottom has a x squared minus 3x minus 18. So I'm going to work on the vertical asymptotes first, but I will be factoring that top to see what factors it has, because it's a trinomial also. So first, I'm going to set the bottom, x squared minus 3x minus 18 equal to 0. So y'all, I'm going to give you the x and the x. How about y'all tell me what numbers we're going to put into these two parentheses? See how good y'all are getting on that factoring. Oh, 3 and -6. Good job. Last one was negative, so we had a plus and a minus. Factors of 18, that subtracting give me 3. We're 6 and 3. The larger one, the 6, had to have the same sign as the middle. All right, so finishing them out, let's knock out our asymptotes by subtracting 3 from our first one and adding 6 to the second one. So y'all on the side right here on the top, we need to factor it just to see if we get one of these two factors up here. If we don't get one of them two factors, we keep both of these. If we do get one of these two factors, we cancel the one that matches, okay? So let's just play with the top, x and the x. So y'all give me some numbers for the top that y'all put into that. Plus 5 minus 3, good job. So at that point, the bottom, I had an x plus 3, that didn't cancel. I had an x minus 6, that didn't cancel. So we keep both of these vertical asymptotes, and we get x equals a -3, x equals a +6. So I'm going to do one more of these verticals, and then when we come back Wednesday, we will pick up with the horizontals, okay? So let me do number 10. So tonight, y'all would be able to get through the first 10 of these, okay? All right, so g of x equals x to the third on top over 3x to the third minus a x squared minus 4x. Now this one, since there's a number in the front, I'm probably going to use the quad formula to solve it. Because factoring is a lot trickier when you got a number in the front. So let's start out by setting that equal to 0. So y'all, there's an x3 in that. So my first step would be to find a greatest common factor. What do all three of them have in common? So they definitely all got an x. So you would factor out that x and put everything else into parentheses. So to factor out an x, everybody's losing one x here. So that's going to become a 3x squared minus just the x minus a 4. So we got one. So remember, there's an x3, so we're going to get 3 different asymptotes possibly on this one. So now, y'all, we would factor these problems. So factor this part further. Easiest way when you got a number in front is just hit it with the quad. So the quad would give me 2 more answers. So let's see. I'm gonna go program quad. So A was 3, B was -1, C was -4. When I hit enter, so I don't want that 1.33, so I'm going to turn that into a fraction by hitting enter again. So I get 4/3 and -1. So x is 4/3, x is -1. So now, look at the factors on top. That x to the third is really a x times the x times the x. So do I have any factors that might cancel out? Well, y'all, I'll tell you this. It's not going to be the 4/3 into -1. Remember, those would be in parentheses technically. So these two factors are not going to cancel out. But look here, you got a single x. On top, you got an x to the third. That's like an x times the x times the x. So don't this single x here cancel with one of them x's? So if you got single x's on bottom, single x's on top, those will cancel out so that my only vertical asymptotes will be x equals 4/3, x equals -1. The factor of x on bottom cancels with a factor of x on top to create a hole in the graph. So let me pull my calculator up and I want to show y'all what happens on it. You're not going to be able to see the hole on the calculator when I graph it. But you'll be able to tell there's a hole there when I show you the y values. So I'm just going to graph this in real quick for us. So I'm going to clear that screen. So let me share this screen now. All right, so I'm just going to graph that with my hand. I'm going to go to y equals, clear that. On top, I had an x to the third. And that's going to be divided by the bottom. Now, since I got more than one part on bottom, I'm going to put my bottom in parentheses. I had a 3x squared minus a x minus 4. All right, so let me show you the graph. So right here at 4/3 and right here at -1 on this graph, those are making up and down. Those would make my vertical asymptotes. At 0 here, well, let me go to the table. You can tell easier on the table. So when I go to where x was 0 at, so notice at -1, I get an error. Oh, where was my other one? Where's 4/3? Going the wrong way. So 4/3 is like 1 1/3. Oh, okay. I ain't got my scale set over here. But all these errors that you're seeing on this graph, these errors are happening where it's undefined at, okay? So I would have to set my table to thirds. So let me do that. Let me go down here where the delta triangle is and do thirds. Now let me look at that table. So 4/3 would be 1 1/3. So I should get another. There's the first error, and there's that second error. So the two asymptotes gave me my errors still, okay? Only trick is you're just not able to see those, you're not able to see them holes. So the graphs are too, not enough pixels. So I want to look at that. Let's see. Also, number 10, when they want the asymptotes, they didn't want us to graph them anyway. So never mind, I guess. All right, so y'all tonight. So tonight's homework. Work 5.1. Work 8.5 up to number 10. We'll start with 11 next class. It'll start doing horizontal asymptotes. And then the last few problems have us do sort of everything. On the last few problems, let's see what they want. They're going to want us to find X and Y intercepts, domain, all the asymptotes, and then graph it. So next class, we'll have longer problems toward the end. So we'll finish 8.5 and we'll knock out 8.6. 8.6 has only got like 6 problems in it. So y'all, this week we'll have all the material done for test 3, okay? All right, y'all. So what questions do y'all have? So where'd my chat go? All right, y'all, I'm not seeing any questions. So let me stop our recording. I'll get this sent out to you. And then we'll finish 8.5 and 8.6 on Wednesday, okay? All right, y'all have a good day, and I will see y'all Wednesday.